Okay, whatever we have covered in yesterday class, on that basis, we have to do some questions. So let's start with this question. So first question is why NO2 is unstable or why NO2 forms dimer. That means dimer means two molecules combined with each other. So why it is so, or why NO2 is unstable. Anyway, it can be asked. So if we draw the structure of NO2, we get like this. N has 5 electrons to, and oxygen forms. We know that either it will form one double bond or it will form two single bonds. So let's make this one double bond over here. Now oxygen has completed its valency, isn't it? Now nitrogen was having 5, 2 it has taken from this, and 7 ho chuka. So 1 it need, so it will take 1 from this, and this but oxygen needs 1 more, isn't it? So what it will do, it will coordinate, it will take 1 electron from this. So with respect to this, if we check that oxygen will have, this is the 2 lone pair, and this oxygen was having it has shared only 1 electron. Yes, so how many? 1 2 3 4 5 6 5 electrons will be there, isn't it? Because 1 electron it has shared with the nitrogen. Done. Okay, so now nitrogen, just check the nitrogen has shared 2 electron with this. Yes, out of 5, 2 it has shared with this, 1 it has shared with this, and 1 it has given to oxygen. So what left? 1 electron. Yes, on the nitrogen. So actually here this nitrogen NO2 is an odd electron molecule. This is considered as odd electron molecule. That means the left electron is not in the pair. Okay, odd electron molecule, and that's why to get the stability, it forms dimer. It forms dimer. Okay, how? Just let me show you. So what we will do, we will take 2 moles of NO2. So what will happen? This here I can make it like this. Yes, I'm making like this, and now this is. So we can show here is as a covalent bond, that coordinate bond. There is no problem at all. Or if you to be more specific, you can make this single bond over here also. Okay, so what will happen? This odd electron will again we will take the 2 molecules as I told you, and like this here. Yes, so this electron will combine with this, and this electron will combine with this. So what will happen? This will form, finally it will form a bond between this. We can mention like this. Yes, like this. Got it? So what happened? This is going to form N2O4, and N2O4 is a dimer of NO2. Got it? So this is the thing that why NO2 is unstable or why NO2 forms dimer. Unstable because it is odd electron molecule. Okay, and why it forms dimer? Because it is odd electron molecule. So that's why to get the stability it forms dimer. Okay, now the question is, what is the maximum covalency of nitrogen? See, you should very carefully with this, that covalency, that means number of bond formed. Okay, so whatever the covalent or the coordinate bond, that is called covalency. So let me define this covalency first. Covalency is the number of bond. Okay, number of bonds formed. So if we check any structure, you can check for nitrogen, it will form maximum 4 bonds. Let me show you here. You can see maximum 4 bonds it can form. 1 2 3 4 1 2 3 4 1 2 3 4 everywhere. Yes, so this is the thing. So the maximum covalency that you have to learn, maximum covalency is 4. Yes, so that is the point to learn. Covalency is equal to 4 for the nitrogen. Now next thing, question is there, out of all oxides of nitrogen, which one is not having an N bond? Just remember the structure of all that compound, all that N bond. Nitrogen oxides, if you are talking about oxides of nitrogen, which one is not having an N bond? So you just check the structure, it is N2O5. Let me show you again here. This is the structure of the nitrogen compound. We can see this is the anion bond, this is the anion bond. Okay, this is the oxides, so anion bond is there. This is also oxide, so anion bond is there. Yes, but this one is not having anion bond. It is NON bond. Yes, so what we will write? N2O5. And how it is? Just draw the structure, and the structure is like this. Yes, done. So this is the compound N2O5. Now we have to go through with this next topic, and that is dinitrogen. So we have to learn few compounds of nitrogen. We have to know about the few compounds of nitrogen. Out of that, the first one is nitrogen. Okay, dinitrogen or nitrogen, you can say. So we know that it is forming triple bond between N and it has low catenation power. So that's why it only exists as N2. Cannot be 4 or 3, something like that. And there is a triple bond, high bond association enthalpy. So it is almost inert. Yes, that I have explained in previous class. Okay, in the lab these are the reactions we have to learn, but I'm going to tell you the trick for this. Okay, just you can make it the short point over there. See, if a compound is in the minimum state, first of all the thing is that in every reaction there will be both the oxidation and reduction. Got it? If oxidation is occurring over there in the reaction, for sure the reduction will be there. There is no such reaction which will show that only oxidation is occurring over there or only reduction is occurring over there. Yes, so if one element is undergoing oxidation, so for sure another element will be there to be reduced. Yes, this is the first point. You can write it here. Now the second point, if any element is in between the oxidation state, and it is reacting, not hydrolyzing, okay, or hydrolyzing even on a hydrolyzing also. So if it is in between, the same molecule will undergo the oxidation as well as reduction. Are you getting it? That means disproportionation reaction के chances हैं वहाँ पे. Yes, got it? So that means if the element is in between the oxidation state, that means it can be oxidized or it can be reduced. Both हो सकता है same element का, या दोनों में से कोई एक हो सकता है. ठीक है? Clear? So this is the 2 point over here you have to keep in your mind. Third point with the reaction we will do. Okay? See, this is I will write it the 2 points afterwards. Okay? So in the lab, when ammonium chloride is NH4Cl, and sodium nitrite, which is NaNO2, when they react, they form dinitrogen. How to form? This is the learning, but how you can think of it. So this is, if you will find the oxidation state, what it is? -3. And if you find the oxidation state over here for this nitrogen, it is +3. Just check this oxidation number. You can find it very quickly, by your own you can find. Yes, you know the way how to find. So what it will be? One is in the least, and in the next, so what it will be, the next compound which will form in the product will be in between somewhere, like the same element is in the least and in higher state. So there will be a compound form jahan ye same element is going to be oxidized and another this N will be reduced. Are you getting it? Because I told you that the oxidation and reduction both should be there. Yes, so you just think will form this N2, and which is in 0 state. You can see that this nitrogen is undergoing oxidation. Yes, oxidation. And here this nitrogen is undergoing reduction over here. So that means the condition that oxidation and reduction both occur simultaneously, that is fulfilled over here. And this type of reaction in which the two different compound having same element is undergoing oxidation as well as reduction, that is called comproportionation reaction. Okay, what is this? Comproportionation reaction. And the opposite of this reaction is proportionation reaction. And the opposite of this reaction is disproportionation, in which the same element was going to convert into was reducing as well as oxidation. Suppose that N2 if forms this and this, then this reaction if you reverse, then this reaction will be an example of disproportionation reaction. Got it here? Okay. Now the second example. So here you can write that it in between it will give you the compound. If the same element are there and in the two different oxidation state, then we have to find such element which is in between oxidation state. So you can see, let me show you that this is the table. Here it is -3 and here it is what, +3. So what do you have to do? You have to write any of this compound. You can write any of this compound. अब इन compounds में लिखने के वक्त तुम्हें सोचना होगा कि there is like, if we will write oxidation and what compound, which one is the stable one in this. If we talk about this, so as I told you yesterday also, this is -3, 0 and +5 is the important one. Yes, so 0 state is more stable, that's why we will make this compound. Clear बच्चे? Okay, so now next thing, on heating, ammonium dichromate also gives N2. How come ammonium dichromate? This is here. If we find the oxidation number, you have to keep this thing, the 2 points what I told you, that should be in your mind. This is -3. Just find the oxidation number of N here. It is -3 and the chromium is in +6 state. You can find the oxidation state. Yes, you all are very well known of this. चलो, so now अब चेक करो, नाइट्रोजन इज द मिनिमम स्टेट. नाइट्रोजन तो अब क्या है, इट इज इन द मिनिमम वन. अब इससे नीचे तो जा ही नहीं सकता. दैट मीन्स ओनली ऑक्सीडेशन इज पॉसिबल फॉर नाइट्रोजन. यानी नाइट्रोजन को हर हाल में ऑक्सीडाइज होना एंड इट कैन गिव ऑल दिस प्रोडक्ट. इसमें से कुछ भी प्रोडक्ट ये दे सकता है. विल डिसाइड आफ्टरवर्ड कि कौन सा प्रोडक्ट देगा. क्लियर बच्चे? ओके, नाउ क्रोमियम. क्रोमियम कैन शो ओनली 2 ऑक्सीडेशन स्टेट, rather 3 state. One is +6 which is in the dichromate, another is +3 which is in the chromic oxide, and third one is 0 which is in the free state. Clear? So chromium is in maximum, so obviously it has to reduce and it has to oxidize. Yes, so accordingly we will write the product, and this is, I told you that +6 से दूसरा ही compound possible है chromium का. What is this? +3 state chromic oxide. Yes, तो if it is not going at the least one, अपने least पे नहीं गया, chromium free state पे नहीं गया, तो obviously this won't be go at the highest state. तो in between जो stable state है क्या है? -3, 0, +5. So 0 वाला state हमने बना दिया. You can check. This is undergoing -3 से it is going oxidation over here, and this is +6 to +3, it is reduction over here. Got it? So this concept you have to keep in your mind, and after 1 or 2-3 lecture हो जाए, so that you can collect some reactions. So write the reactant all and try to write the product by your own. Got it बच्चे? चलिए. So now the next thing is N2 can also be obtained by heating barium azide. Before this azide, I just want to tell you 3 things. Like this is, let me write it over here only. If it is N2, what we say? It is nitrogen. Yes. If it is N-3, one nitrogen has -3 state, then it will be called nitride. And if 3 nitrogen is having -1 charge, then it will be called azide. Yes, got it? If 3 nitrogen is having -1 charge, it will be azide. And one more, if N is attached with 2 with double bond, here also N2, this is also N2, but what is the difference? This is N triple bond N. Yes, and this is N double bond N. Then it is called azo. This is the common point that you have to keep in your mind. Yes. Okay. So if I said that barium azide or any metal azide, so azide is N3 minus. Yes. So azide is N3 minus. Yes, done. And barium I'm saying. So barium is having what charge? +2. So if I will take barium +2 and N3 minus, what will be the compound formed with this? Yes, in class 9th only you have done the cross, and it will give you BaN3 whole twice. Yes, this is the barium azide. If I will ask the structure of sodium azide, you can write NaN3. Yes, so if it undergoes heating, it will dissociate to give what? अब यहाँ पे देखो, this is in -1 state. Yes, N3 is in -1 state and Ba is in +2 state. So what will happen? Barium shows the only two oxidation state. एक तो +2 है और दूसरा क्या होगा? Free state. All the metals shows 0 state in its free state. और सारे के सारे मेटल जो है free state में होते हैं, दिखा सकते हैं. They can show and that is 0. So barium has to, ये तो maximum है तो obviously it has to reduce and reduce होके क्या देगा? It will give you Ba free state. Yes. And the nitrogen N3 is -1. So you just check in this, after this -1 state, which state is given here? This is -1. So what is the compound after that? We can write N2, isn't it? Got it? समझ में आई बात? This is -1 state. -1 के बाद आपके पास कौन सा state है? 0. So you will write N2 over here. Now to balance, it will be 3 and it will be Ba. Okay, done. So that concept is also that there, that it is undergoing, ये 0 state है, ये भी 0 state है. So here it is -1 to 0, it is oxidation, and +2 to 0, it is reduction. Okay dear. So this is the concept. आपको concept use करना है, and the same concept you have to apply in one way or other way. Got it? I hope it is clear. So after this, let's do with the chemical reaction of nitrogen. That was the preparation method, how to prepare the nitrogen, and now how the nitrogen reacts with other. Okay, so this is again an important point. It is going to come. Nitrogen reacts with metal. It gives metal nitride. Yes, कैसे? Let me see. Nitrogen is this N2. Yes, and metal. Any metal you can take. Like I'm taking Mg. Okay, so let it be. Now Mg, we know that the oxidation state of Mg is 0 over here. Nitrogen is also 0 over here. So Mg has no chance. Mg के पास सिर्फ दो ही oxidation state होते हैं. What are that? Mg +2 and Mg 0. Yes, metal we know that. So Mg अगर हम जाएगा तो this is going to be oxidized. Obviously it will be oxidized, and oxidized होके ये क्या देगा? Mg +2. Yes, isn't it? Got it? And see in this nitrogen, if N2 is here. So if it undergoes reduction means it will go give out of these products. इनमें से कोई product देगा, इनमें से कोई product नहीं देगा, because ये product तब आएंगे when it is going to be oxidized, and ये product तब आएगा when it is going to be reduced. So nitrogen is going to be reduced, isn't it? So 1, 2, 3 product we have, and moreover I have told you that these are the three important things, that -3, 0 and +5. So obviously this is going to be most stable compound, and this will form. Yes. Now -3 state we have 3 compounds. NH3, can it form? For making NH3 it must have some hydrogen. Is it there? No. Can it form NH4 plus? Again no, because no hydrogen is there. So what else it can form? N-3. So that means nitrogen has to reduce in N-3. Yes. So make the compound of this. We can write this 2 over here and this 3 over here. Can we write? Yes or no? Tell me. So this is called magnesium nitride. Yes, I will use this fluid over here too. Okay, now it is clear. Similarly, if I will tell you to make the compound with sodium, make the compound with the sodium. Another example. If nitrogen reacts with sodium, tell me fast, what will be the compound formed? Obviously, yes, very good. NaN3, because Na has +1 and N3 has N3. Here it will be what? NaN3. Sorry, it is Na3N. Sorry. Yes, because N has -3, na? So that's why it will form Na3N. Similarly, if I will say to make the compound with aluminium and nitrogen, what will be the compound form? Tell me fast. Aluminium +3 and nitrogen -3. So both will be cancelled and it will form Aln. Any doubt? Now, nitride, all these nitride which is formed on further hydrolysis will give ammonia. क्यों देगा? Yesterday only we have done a topic, we have done that concept, that compound in which element is in minimum or maximum oxidation stage on hydrolysis, it do not undergo redox reaction. That means oxidation number won't change, isn't it? So what is that? This is nitride is -3, Yes, if nitrite is -3, so what are the other compounds which can be formed with the -3 state? These two. So on hydrolysis, yesterday only I told you, on hydrolysis nitrite will give you ammonia. Yes, so make the compound. So if I am writing any like this is Mg3N2, if this is undergoing hydrolysis, obviously this nitrogen is going to form ammonia where there is no change in oxidation state. Here also it is -3 and here it is also -3. So if there is no change in nitrogen की oxidation state पे कोई change नहीं है, so obviously magnesium will not change any oxidation state, because I told you either in the reaction both the oxidation reduction should be there or no oxidation reduction should be there. Yes, या तो कोई change होगा, अगर change होगा तो दोनों होगा, और अगर नहीं होता है तो it won't be. So Mg+2, make a compound Mg which should be in the +2 state, and with what? This nitrogen we have used, hydrogen and oxygen are left, you can use. So use this compound, use this ONH to make a compound of magnesium in which the magnesium shows +2 state. What is that? Yes, very good, it will form OH. Similarly, if this reacts with this water, what it will give you? This will give you NaOH and ammonia. Similarly, if this reacts with water, what it will give you? ALOH whole thrice and ammonia. Yes, any doubt in this? Okay. Now, another reaction of nitrogen, that is a very famous reaction, and that is Haber's process. Haber's process says that nitrogen, when reacts with hydrogen at low temperature, this is the condition, we have done in thermodynamics class 11th. Low temperature, high pressure, and in presence of catalyst. Yes, so that it will give you ammonia. So let me write the reaction. This is, if I am writing N2 plus 3H2, it will give you 2NH3. And what will be the condition? The low condition, low temperature. Why? Because it is an exothermic reaction and heat is released, or delta H you can write in this. Delta H is -46.1 kilojoule. No need to learn, as I told you in class 11th also, but मुझे याद है, तो that's why I have written. Okay, the condition is low temperature. Another condition is high pressure, because volume is decreasing. So according to Le-Chatelier principle, we have to provide the this is pressure. We have to provide the pressure, high pressure. Yes, and since at the low temperature the reaction becomes slow, so we have to use catalyst over here. ठीक है, समझ में आ गई बात? So this is the reaction. Next reaction is that dinitrogen reacts with oxygen at very high temperature to give different oxides. Many oxides it can give. It depends upon the number of oxygen, how it reacts. Okay, suppose that N2 is reacting with the one oxygen molecule only, it will form 2NO. Yes, if this N2 is reacting with two oxygen molecule, what it will form? N2O4 यानी और NO2 कह सकते हो. Yes, 2NO2 or N2O4 you can say. Another, if N2 is reacting with 3O2, what it will form? Simple सी बात है, this will form N2O3. Yes, and if N2 is reacting with 5O2, what it will form? N2O5. So it depends that with how many what moles it is reacting. Yes. Now there is the uses. We have to do this uses of nitrogen. In the first class only first lecture only I have said this, it is least reactive, so that's why it is used for providing the inert atmosphere for the tables, like the chips packets are flushed with this nitrogen. Yes, to make it fresh and all that, to keep it fresh or also. Also used as refrigerant. Earlier जो है वो that was CF2Cl2 was used as a refrigerant, but there was the ozone layer depletion, so after that it is stopped, and now in the ACs, in the refrigerant, or wherever we have to keep the temperature down, there N2 is used as refrigerant. Okay, and this is also used to preserve the biological specimen. ठंडे टेम्परेचर पे रखने के लिए we use this, and also used in cryosurgery. Cryosurgery, that means the surgery which occurs at the low temperature. Cryo means low. Okay, so low temperature पे the surgery which occurs, so there to maintain that temperature we use this nitrogen. Got it? So this is the uses of, these are the uses of nitrogen. After that we have to do that next we will do that ammonia. Okay, so that tomorrow we will do, and till then, thank you class.